Hello, hello. The name is Amazon software engineer. Things like real-time systems, just like WebRTC media strips, real-time technologies, basically. And in this video, I want to show some WebRTC concepts. So you understand about WebRTC, right? And yes, I mean, things for another book. So let's dive deep into it. All right, let me set my evaluation. Let's go. So, if we are, let's go. I think you can see my screen. Good enough. So we can change the timeline from Twitter. Let's go. Good enough. So, first of all, what is your what is it? Yes. It's an protocol we use to share some data directly peer-to-peer. Peer-to-peer means from a browser to browser. So our data don't have to flow from the server. We can two browsers directly can connect with each other and share data directly. So and because we're sharing directly data from browser to browser, we don't need a large server to exchange data from each other, right? So it helps us to optimize our cost by computation. Right? And when we use WebRTC, things like uh, a two-person need to connect to each other, right? And they want to communicate to each other or share directly. Like, for an example, they are connecting to a video game, let's say. The video binaries or video bytes need to flow from here to there, right? So you can your digital and share data directly, right? We'll walk you through how it works really step by step. So let's go down and let me go over the next slide. How WebRTC works. So mm, if we think in first principle, uh, first what we need to do is just capture an video or audio from this web and connect to another peer and share share data directly. What I told you before, right? This is what you understand. So, but there is some things we need to understand before WebRTC, uh, like what is what is turnovers. In the video, I'll walk you through all the things what it need we need to know about WebRTC, right? So let's go through how WebRTC works. The first point is capture camera map. So what we get initially what we do is from unpeer from a peer we capture your camera or mic or send only audio code. Then we capture only mic, right? When the when you capture mic, we get the information or the bytes of audio, right? Then we confirm that yes, we can access now camera and mic. The next thing is we exchange offer and get the answer via signal. What offer is, what answer is. Let's understand it. Let's suppose I want to connect to you and I want to uh, talk to you time. And if we think from first principle, like a simple code, like a phone call, right? Or what we do is I just type your number and directly call you. And either you accept my call or reject my call, right? Sure. Offer is just I am calling you. You are answering my phone or don't answer my phone. That is the future, right? Initially, I'm just offering you or want to connect you. So I just send an follow. If you also want to connect me, you give me an answer. Yes, I also want to connect you. You know, this is happen through signaling. Signaling is just nothing. Signaling introduce each other through the weapon, offer and answer. Instead, right? Let's go to next step. What exchange I see is what I see is just I I see nothing just to know each other that what codec or uh, what is the perfect way or the best way to connect to each other. Because I just told you about student learning. So I'll walk you through in this video what is studying terms in it. We'll discuss about something better. So exchange IC is just to know each other. What is the perfect way to connect? And yes, everything for if we need to understand ICD, then we can cover the end, right? Let's go to the next slide. I think, oh, okay, fourth point is left. But, okay, we get the perfect way to connect to each other, right? And now we establish peer-to-peer connection. So significant, right? We establish the connection through significant. We exchange offer and answers. So the final is two peers are connected to each other through WebRTC, through signaling. Signaling is a sub-part of WebRTC. Through signaling, it's connecting each other. Now they can share data. But before, because I don't know, see, data is shared through directly, right? It's browser to browser. These things, these things are happening through the server. Basically, this happen locally, capture camera mic and exchange offer answer via signal. We exchange the offers and answers through my server because my server knows who the other person is. Right? So one person said that I want to connect to this person. What my server under the hood do is it send my offer to the another peer then if that peer also want to connect to me, that he will send the answer to my server to the first peer, right? The offer and answer are exchanged, then they they try to connect that through I see candidates figure out what is the best way to connect right? And in the end, what we get is two players get established connection. Now they can send data to after some time you'll know how they send data there because till now we understood how they are connected to each other, right? So audio, the video is about yes, let's go ahead. Both components. Good. These things initially can be jarring, but it will when by one what these are right. Uh, through the get user media, this just netting is just a function to get the camera and microphone access through the browser. And if you approve that, but we got the camera and microphone access and we can access your camera by basically access your camera what camera is recording. We can basically we can access your video real time, right? With video and audio. What our TCP connection allows it builds the connection from one peer to another peer. And what RTC data channel do is it send the data and audio, video between each and from one peer to another peer. You got it? RTC peer connection connect two peers. RTC data channel sends the data, the chat files you can say audio, video, files, right? So yes, let's move to the next slide. Signaling. Signaling is not part of the WebRTC standard because we are just connecting to each other. After we connect, then the WebRTC part begin, right? So signaling is just to connect two peers each other so that they can share data through WebRTC after. Like, uh, okay, usually implemented with WebSocket socket or I just said that the initial connection built through the server. So the both clients be connected through a server that uh, exchange their offers and answers to each other so that they can figure out each other who they are. And basically, it's a middleware we can say that exchange some information from one peer to another peer so that they can find each other and connect to each other. Right? Exchanges SDP over SDP ISO and ICP. I just said SDP offer is just making us a person respond to connect to another person. And SDP offer, SDP answer is nothing, just another peers who received that offer also manage to connect to the first person who sends an offer, a offer, right? And I see candidates is nothing, just figure out what is the best way to connect those people to each other. And the next thing is SDP. SDP describes codecs media capabilities. And right, SDP also provide some codec media capabilities. let me understand what codex is, what media capabilities is. Codex, codec is just an way how we can ship. I think in a simple term, how we understand codec is let's in one line what codec is. So yes, codex. So yes, co- here we are. So yes, what codec is? It's just an way how we encode, encode and decode script. So yes, codecs is how, just how we encode some video, audio, or the data. There is multiple ways. I don't remember the exact name. There is that there are DTLS SRTP is the way to mm, so yes, but codex is just a way how we encodes the data we are sending. It, for example, it can be in audio, video, or some text data, right? So we need to code that data so that we can see the actual data. Because initially it's in just 10 buffer. We need to uh, decode that, right? Mm. So yes, codex is nothing is just a way how we encode our data or audio, video, or just in text. Right? So we can decode that data so that we can see the actual data. Because initially, when we get the data from the another field, it's just an buffer. We need to decode that. Right? The second is media capabilities. It basically means the what another person, uh, another person's data media quality has. Media quality is just nothing. Is just an for example, it's just let's suppose we have a video that can be 144p, 180p. Right? There is multiple ways. So is it just define what are the capabilities, what are the ways we can access it? Because if you want to access just an 144p video, then we just need an less data speed, right? So if we have multiple capabilities, let's suppose just like YouTube does, and video have multiple capabilities. It can be HD, low quality, full HD, 4K videos. Based upon your network, it's so that video to right. The same thing is here. One peer's video can have multiple media capabilities. Media capabilities is nothing, just um, its quality we can say, right? based upon your network, you can see that video. And yes, ICE, it just finds the best network for so that two peers that connect to each other. It peers exchange IC candidates interconnected. And peer connection. So if two peers aren't connected to each other, they are repeatedly trying to exchange IC candidates so that they can connect it. If both peers received another peers IC candidates, it means they are connected to each other. Then after that, they can share data with each other, right? Let's let's move to the slide. Yes. And what is stun? What is turn? So stun and turn is a way to connect to each other. That like and what I see was that finds a way finds the best way to connect to fish. So there are the things stun and turn. Stun is nothing, just it finds a public IP for direct connection. So if one person, the same example, if one person wants to connect to another person, it just wants to another person to public IP. If we get it, if he get it, then they can connect directly. But what if the another person uh, con- is the what if the another person is connected to an router that includes some firewalls? It means the you can note access is public. So then we use terms over realize traffic when direct connection is. If we can connect directly, only if we get the another person or another peer, the public eye. If we didn't get it because of some NATs or firewalls, then I see we can figure out, oh, this done connection phase was like, get publicly. So let's use transcenders. But there is some case to use transcender. It is slower because uh, your data. Uh, slower, it's because the direct peer-to-peer connection fails. And your data need to go through some another server. We can say turn is let's turn is just a third party server that provides uh, to exchange your data from here to there. So then it means should because it's a server, so that it need to process that data. So it needs some CPU cost. So that is that increase your cost by it's not basically yours. You just need to pay those third parties to use their bandwidth, to use their CPU to right. So and when we create production based projects for the apps for WebRTC, we usually provide both the stun and downside. First, IC tried to connect with the stun. It just tried to find another pure public IP, and if it fails, then it tried to connect to the transmission. And then servers provides 100%. Uh, you can see they provide that they surely exchange your data perfectly. Right. Sure. In the end, we use Taxona because we need to pay here, right? And I think let's another slide. What is the connection flow? We discussed earlier. It's just simple. We get the user media access, just like camera, micro, or display things. Displays. There's nothing else. If you want to share the screen, right? And we create an offer on if peer wants to connect to another person. So it create an offer and send through the server to the another person. Send via signal, right? And create and show the another player create and also check the yes type also want to offer share, then exchange IC. IC is just nothing, right? They so that they can find perfect path to connect to each other. Exchange IC, find out the best way to connect and peer-to-peer media starts. So yes, now they can share data directly from one cloud internet. Right? The next thing is security and use cases encrypted using DTLS SRTP. One DTLS is just uh, algorithm is a way to encrypt your data when you are sending from here to there, and SRTP is do the same. And the next thing is they also used things like Google Meet, Discord, Teams, and more production apps, the large scale apps. Right. Yes. Let's go to the next slide. The summary. About is it provides secure, low latency, real time communication. Low latency is just because they one peer can connect to another peer directly. Your data don't need to flow from the server. So that's why it's fast. Provides training. We encode, decode the data. So we just discussed about DTLS as well. So it's secure. It securely exchanges your data from on your wallet. And signaling exchange connection information through the signal we exchange the offer and the issue. The STEM discourse public IPs. Then one peer find out the another peer's public IP. He got figure out who cannot discover the another person peers public IP then in the phone doors try to connect to the turn. So it relies and P2P is investment. If the stump is failed, then we cannot it just because now our data is flowing through the third party server to the another party, right? So that is about the today's class. If you have any questions or if you have if you want more detailed video, let me know in the comment section. I will open to you. It's in the